Hey everybody, it's Keith with BobsCNC. Welcome to Shop Talk, and I'm here as always with my best, well, he's my best friend, Bob.
And he's my best friend, Keith.
And we're going to talk.
I'm pretty confident about it.
Yeah, I guess so. Anyway, we're going to talk about home switches.
Yes, we are.
And the different types of switches, and why we use them. And I don't know, why are we even talking about this, Bob?
Well, we're going to go into basically the self-squaring gantry, and we get some emails and some phone calls of this doesn't work, why doesn't this work? So we thought maybe if we could just kind of walk through home switches in general and the theory behind our self-squaring gantry, it would help out.
Yeah.
So you ready?
Yeah, I'm ready. Go ahead.
Okay. So the first thing that we're going to do is just talk about switches. Now there's lots of different kind of switches, but there's two things that make the switches that we use work well. First, they're momentary, which means if you push the switch and you let it go, it goes back to its original state or its original circuit, right?
Or it's normal.
It's normal, yeah. Hey, that's good. Normally open, normally closed.
Something about the language just made sense.
And then you have another type of switch which we do not use, and you would understand. They're latching switches.
Okay.
So when you click them, like a light switch at your house, they stay in that condition until you flip them or switch them to another condition. Okay. So the latching switches we don't use, obviously, for homing, because when it bounces off, we want it to automatically go off, right? And so we use momentary switches, and we use normally closed. But let's talk about normally open first.
Okay.
Okay, so normally open happens when the circuit is normally open. So the switch is not being pressed. The switch is open, so there's no electrons traveling through that wire.
Right.
So it's an open circuit, the wires aren't touching. Right? So when we press that switch, the lever comes down and it closes that contact, or it takes the two switches or two wires and puts them together, making the electrons flow. Normally open.
Right.
So we use a normally closed switch. So typically it's closed, the wires are closed when it's in this position. And then once you press it, it opens the contacts and breaks that, right?
But now, when it's momentary, how does that apply? Normally closed, I flip that switch.
Right.
It's either on or off. Here, you've just touched it, but now it goes back to its normal condition.
Yeah, so as soon as you release it, it's spring-loaded, it pops back up, and now it's closed again.
Okay.
Okay?
So it only opens and closes.
Yeah.
Right.
So when you activate it, it goes to its other state. So it's normally closed.
Right.
So when you activate it, it goes to the open state. You let it go, it goes back to the closed state.
All right.
So why do we use normally closed? It's an industry standard. If you were to break a wire somewhere or your pin came disconnected, right, this would show up on your screen as, hey, the home switch being activated. You would look at the home switch and say, no, it's not. Something's wrong. My home switch is defective, or I got a broken wire.
Right.
Whereas if it was normally open, you would not be able to know if that switch was disconnected or not because it's normally open. Okay? So normally open, normally closed switches, we use the normally closed. So if we go on to our self-squaring gantry, which is really what we want to talk today with this information, how does it work? First of all, it is wired in series, and I'm hoping this diagram will help you out. So we go from the 2-pin connector here, this black box, right, which is going to be connected to your Z+. It's going to travel up and hit one switch, and then the next wire is going to go to the other switch, and then the wire is going to come back around and go to the 2-pin connector.
That it has to hit that Z switch first.
Well, actually it doesn't, because this is it's just a closed circuit. So you notice since it's closed, there's a closed circuit, so electrons can flow here and give the signal that that everything's happening. It does not matter which switch I open up, right? It will send a signal.
Okay.
So Sonny, the lead developer of the gerbil firmware, came up with this. We don't have enough pins on the microcontroller to just throw it on its own pin, so we had to share a pin. And the reason we can share the Z pin is because we home the Z first. The reason we home the Z first is to make sure that it gets out of the clamps and the material. So it's industry standard to get the Z up first and then get the X and Y out of the way, right? So because of this, we were able to use or Sonny, with his clever design, one pin to actually home two different axes or the side of the x-axis. So the x-axis actually homes independently, so, meaning the gantry on one side is independent of the other. So if it's at an angle, they will straighten out and then back off, and your gantry will be square. So let's just kind of walk through what happens. So when you hit the home button, as we said before, the Z homes first, right?
Right.
So the Z homes first, and it's going to break that Z home switch. And the microcontroller is going to assume that's the Z, and therefore bring this, the stepper motor to a stop, let it lower, and come back up, and it'll bump it again. So now that the Z is homed, it's going to go ahead and home the X and Y. Now as soon as the X2 switch hits, then it knows that that is the X, because the X is the stepper motor that's turning the X and Y. So it assumes that that's the X2, and it takes that motor and stops it and backs it up. So therefore you can have the self-squaring gantry. Now I did notice something that's happened since we've released the Evolution that I hadn't thought of, and I actually have not even talked to Sonny about this. But if the gantry is up against the back wall, therefore the X2 switch and the X1 switch is bumped, but mostly the X2 is what's happening here.
Right.
And you click the home, what's going to happen is the Z is going to go down because it's assuming that this one is open, right?
Okay.
So the easy fix for that for now is just to unplug your machine and pull it off the back wall a little bit before you initially home it. You should be taken care of there. It actually shouldn't get to the back wall, right? Because when it homes, it always backs off. So left off in that position, it shouldn't there. But if you have a problem where you know your machine's working, but all of a sudden the Z is going down, unplug your machine, move your gantry off the back wall and see that, or take a look at your home switches. We do have some videos on diagnosing home switches.
So guys, if you have any questions about how your machine operates, any topics you'd like us to handle, we'd love to hear from you.
Yes.
You can get a hold of us at shoptalk@bobscnc.com or at the help desk.
Right, either
at
way.
BobsCNC. So I guess till next time, we'll see you.
See you guys.